Hi, everyone, and thank you for listening to our presentation at Virus Bolton 2021. Today, our presentation is titled Uncovering Automatic Obfuscation as a Service for Malicious Android Applications. I'm Masarah Paquet-Clouston from GoSecure, and this research was done in partnership with Sembera from Trend Micro, as well as Sebastian Garcia from the Stratosphere Laboratory and Maria Jose Erquiaga from Cisco System. So what is today's presentation about? Well, it's going to present the results of an investigation we did of an obfuscation-as-a-service platform for Android applications. So we know a lot that, the cybercrime industry is characterized by specialization. So individuals offering services, specialized services to other individuals. However, there's few studies that have looked, specifically at a service, such as an obfuscation-as-a-service, understanding the techniques that it uses and the business, context in which it evolves. So this is what we tried to do in this investigation, and this is what this presentation is about. It's divided in 3 sections. So the first section is me. I'll be presenting the story, how we encountered the service and, what the platform looks like and all. The second part of the presentation will be about the reverse engineering results. So we ended up obfuscating applications, and Sembera reverse engineer them. He's going to be presenting the results. And the third part of the presentation will be about the business of obfuscation, specifically for this service. So how we try to kind of depict, the reality of the individuals behind the platform in terms of competitors, efficiency, or potential profitability. So let's start. Part 1, the story. So it all started 2 years ago when Sebastian Garcia, Maria Jose Erquiaga, as well as Anna Shirokova were monitoring the HGBot proxy malware and ended up uncovering the GS botnet. So the GS botnet is an Android banking Trojan botnet that mainly targets Russian citizens. It has estimated to have made millions of dollars and thousands of victims. The laboratory already stripped down the botnet, analyzed its infrastructures, and presented at Virus Bolton in 2019 about it, as well as Black Hat Europe. So if ever you want to learn more about specifically this botnet, you can always refer to these presentations. A few months later, after these presentations, Sembera from Trend Micro was interested in studying specifically GIOS APKs that were Android banking Trojan. So he ended up taking one and stripping it out completely, uncovering the whole specificities related to the APK, and he published about it called GIOS Anatomy of the Android Trojan Targeting Russia. So you can have all this information also available on Trend Micro's blog. What's interesting is while all of this was happening, the Stratosphere Laboratory, while investigating specifically the GIOS botnet, found a private chat log or a chat log where there was discussions among individuals involved in spreading the botnet. And they knew these individuals were related to the GIOS botnet because they did share information that were specific to GIOS, such as the IP addresses of the CNC servers, as well as internal commands specifically related to the servers. So that's when we ended up forming a group together, as I have a background more in social science, and our goal was to study the specific chat log and understand, what these individuals were talking about, what were the motivations, what were the contexts, what were the challenges. And while we were searching and understanding what was going on, we ended up finding something quite interesting. So one of the guys said, "Do you remember the link for the crypt?" And in this sense, it's kind of a slang word to say obfuscation or protection. And then the other person answered, "Well, this link, fttkit.com." And afterwards, the conversation continued as they were sharing passwords and discussing about this specific service. So obviously, we're all curious. We went on the website and we ended up finding this. So this was basically a portal. You could log in, and then afterwards, you could upload your APKs, obfuscate them for a fee. Notice it says protect here rather than obfuscate. It's kind of one or the other, right? The goal is to hide the intent of the APK. Some of the individual could say it's to protect, the source code, while other could say, well, no, it's to, conceal the maliciousness of the application. However, what we noticed too is we couldn't register without a code. So it wasn't available to anyone, just to create a login with a password, no verification of email addresses. To be able to register, you had to have a specific code. So what we ended up doing is searching in underground forums for this specific forum, and luckily for us, we found that it was quite advertised. So here we found an advertisement in 2018 of specifically fttkit.com on hackforums.com. And as you can see, it is advertised as an automated service for the protection of Android applications. And what's even more interesting is that within this specific ad, you can have a coupon code. So if you use this specific coupon code to log into fttkit.com, or sorry, I meant register, then you successfully access, the platform. So we were lucky enough to do this and ended up, being able to surf on the platform and understanding how it works. Here we're providing you the prices. It's written in Russian. There was an English version, but it wasn't, well developed, so it was working better in Russian. What you can see is it can be between $20 to $50 or $100 USDs to obfuscate APKs. So $20 for one, $50 for three, or $100 for 10. And then if you look at the last one here, it would cost $850 for an API access to the platform for 30 days with, unlimited APKs obfuscation. So the first thing that struck me is it's quite expensive. I guess it's the prices now to have, obfuscation as a service, but $20 for one APK seems to be, quite important. So we ended up surfing, on the platform and thinking, well, what a good opportunity. We could, obfuscate an APK. Basically, you send Bitcoin to an address, and afterwards you upload your APKs, and it automatically obfuscates them for you. So you don't have to interact with anyone. And then afterwards, compare the obfuscated version with the non-obfuscated one, the original that we had. However, we kind of knew that the obfuscation as a service was, its aim was to obfuscate, and thus it was hard to reverse engineer it. And when we looked at Sembera's blog, at Trend Micro, where he completely uncovered the GIOST APKs, we knew that, well, the service was obfuscation. The APKs were thus heavily obfuscated, which could be hard for us as beginners, to reverse engineer. We were lucky because we contacted Vit and asked him if he wanted to join the research, and he accepted. So since then, we've been working together for the past, I'd say, 1.5 years now, and he's joined the project and he's worked with us. So thank you. So our strategy at that time when Vit accepted was to obfuscate 3 APKs. We chose 2 highly malicious APKs, so Android Locker and an SMS stealer, and then one that could be considered malicious but was not obvious. It was a potential adware, and only 2 antiviruses on VirusTotal, flagged it as potentially malicious. However, and then just say we took the $50 for 3 APKs bundle, obfuscated these 3 APKs. However, what we noticed is there was no difference in between them. So there's no point, in comparing them. So we decided to only present the result for the Android Locker for simplicity. So start with using mobsf and do an automated analysis. That's what we thought was the best step. So what we did is we put the obfuscated Android Locker and the original file in mobsf and, extracted information from this. And you can see here kind of a summary. First thing that you may notice is, well, the CVSS score for the original file is 5.9, and for the obfuscated file is 0. So the obfuscation service was good at, hiding the vulnerabilities within the original file. This led to an increase in the security score from 75 to 100 with the obfuscated file. So that's pretty good. However, right away, notice that the package name and the main activity for the original file have, normal words. But for the obfuscated file, it's kind of random strings. And that's, easy for any malware analyst to at least notice that this is kind of suspicious. Also, we wanted you to see that both activities and services increased for the original file and the obfuscated one. For the activities, it indicates that the obfuscated file seems to be more complex. And for the services, well, it indicates that there may be more services running in the background. So this could also hint potentially for more malicious, intent. So this is the first thing that we did. Then we move on right away to the second part, reverse engineering results with Vit.
Hello everyone. Now I will share some details about the obfuscated sample of Locker APK. There will be few examples of the code extracted from analyzed sample, and you don't need to read them in detail. They are mentioned for illustration purposes only. After the compilation of classes.dex file, there are hundreds of similar classes like you see on this slide. Symbol obfuscation can be expected. Here are randomly generated strings of length 6 to 12 characters. But what is this green garbage stored in string variables? Can it be some kind of encoding? I have tried frequency analysis, entropy analysis, but this gave me no clue. And no reasonable Java code can be found in those classes. Few classes contain something like this. It is a Java code, but it does not make much sense. As it was discovered lately, that code marked by red boxes is a junk code inserted to make reading difficult. You can find Boolean, integer, string variables assigned with randomly generated literals, and also if then else, switch case, and try and catch construction, go to jumps, and even randomly edit methods and method parameters. And here is another example using switch command. As you can see, understanding of such code is difficult. Here are tools I have used for analysis. Injected junk code made the compilation task difficult, even for all well-known Java decompilers. Especially nested exception blocks in combination with goto instructions were very hard obstacles for them. So, final decompiled code had to be combined together from different tool outputs. Best results gave me JEP decompiler, which is a commercial product. On the opposite side was Ghidra decompiler, which has been struggling even with simple parts of code. Manual Smalley to Java decompilation has been used in few cases because all decompilers failed in this task. There is still a space for improvement, mainly for open source Java decompilation tools. Python interpreter is mentioned here as it has been used for byte array to strings decryption. When digging through heaps of nonsense code, this piece draws my attention. It looked quite familiar to me. Can it be a piece of RC4 code? After symbol obfuscation and junk code removal, the same method looks like this. Here are corresponding parts of code. The RC4 algorithm has been split by authors between several methods to make itself less recognizable. Here are some of them. Most important for us is this method containing an encryption key. When RC4 decryption method has been revealed, it was clear there is a lot of byte arrays encrypted with RC4 algorithm. They are used as a string constructor argument. Here is one example in original code. The reason is that Java deflection library methods are used, and names of methods and their parameters needs to be hidden. Otherwise, it would be too obvious what the code is doing. So I did a small Python program for decryption of those byte arrays. Then I replaced decryption method, calling by resulted strings directly in the source code. And here is the same code after string decryption and code cleanup. After junk code removal, strings decryption, reflection methods named the obfuscation, we could guess what could be other methods doing and what could be their names before obfuscation. Here is the core of the APK executable code. I will shortly describe what this method is doing. There is a file stored in the APK. This method opens the file, decrypts it using the same RC4 algorithm and key as strings before, saves it with a different name, and then loads it as a DEX module, and finally deletes both files. And the locker is loaded, and activate it now. So this code played a role of a Trojan horse for a malicious Android application. When looking into APK, you can find a directory named tracks. It contains several files with randomly generated names. I did not analyze their contents, but they are not used in the code, so it doesn't really matter. The only important file is the radio awk, which contains encrypted second stage DEX file. And here we have the resulting local code after decryption and decompilation. The only obfuscation method used in second stage is symbol name obfuscation for symbols which are referenced in the manifest file. In comparison, GEOS did also encrypted strings even in the second stage. I'm not sure if it's a joke or attempt to distract attention of the analyst, but there has been always part of code with unobfuscated and attractive symbol names, but always in a part of code which is never executed. This is an example of SQL-like code. So, the result of the analysis is the Java code is a dropper trojanizing malicious Android application. It is heavily obfuscated, and the only task it has is to decrypt second stage DEX file and launch it. It is difficult to perform automated analysis of the dropper, but it's not impossible. To decompile second stage, you need to find a class with RC4 algorithm within hundreds of junk code classes. Then you have to recognize a method containing RC4 key. Hint is, the key byte array is assigned to a byte array variable. The rest of byte arrays are used in place of the string constructor parameter. A key has been different in each analyzed sample. Then you can decrypt and decompile the second stage file embedded in the APK. Be careful, dropper code is evolving. In earlier versions, a file carrying second stage contained only the encrypted DEX file. In later version, a simple header containing the length of the file encoded in 4 bytes has been added. Side effect of this kind of obfuscation was increase in size of the original APK about 32 times, mainly due to inserted junk code. And this is all from short overview about analyzing such sample. Total time needed to complete the obfuscation of first GEOS sample was about 3 weeks, but consecutive analysis has been done in about an hour.
Okay, so this leads us to our third part of the presentation, the business of obfuscation. So basically in this part, what we're doing is try to have a general depiction of the business context in which the individuals behind the platform evolved. And to do so, we developed 4 themes. So service usage, efficiency, potential revenue, and potential competition. So we're going to go over each of them right now. Service usage. The idea here was to have an idea of, how many potential customers the service has. So is it 100,000? Is it 1,000? Is it 10? Just to have a general idea. So to do so, what we had to do is to find APKs that were obfuscated by the service, in the wild. So what we did is we used our reverse engineering results that gave us good insights on the service as well as VirusTotal. We searched, computed 2 retro hunt jobs for any files that were submitted on VirusTotal that were either APK, zip, or jar files that had the radio.ug file name in them. And remember from Vid's presentation, the radio.ug file name is the second stage Dalvik executable that launches the hidden application. Once we gathered, all of this information and had all of these APKs, then we decompiled them and kept only those that had manifest files with activity and service names that were long random strings, as well as, yes, the radio.ug file, but it had to be stored within the /tracks folder, just like, our applications. And most of the applications we found basically, had these features. We only discarded a few, like really not a lot. And what we ended up finding is about 3,058 APKs that were, with a high degree of confidence, obfuscated by the service investigated. Then the second step that we had to do to understand, or estimate the potential number of customers was to assess whether these APKs were the same or not. So it could be one APK obfuscated 3,000 times, or it could be, let's say, 3,000 like unique APKs. So we had to find a way to group them together. So to do so, we investigated the obfuscated application. It was not necessarily super obvious because these applications are meant to be obfuscated, but we did end up finding interesting things that could allow us to group them together. So basically, we noticed that within the res/values folders of the obfuscated application, there was leaked information. So in files like strings.xml or IDS.xmls, you could find strings in clear text. So here we give you an example. You do have obfuscated string names, but you have also strings in plain text that leak information about the application prior obfuscation. Obviously, I don't think that the application that was obfuscated was an Adobe Flash player, but it still gives us information on what it was before being obfuscated. So what we did is we took that information and extracted it from each of the obfuscated application found and grouped those that together that had the same strings in clear text in the end. And what we ended up finding is 7 groups. So 7 groups is basically, let's say within these 3,000 applications, there was many of them that could be grouped together because of this leaked information. What we did afterwards, though, just to confirm, is take a dozen of APKs from each of these groups and put them in apklab.io. If you don't know about this tool, it's really great. I highly recommend you have a look. It's developed by Avast and it's available for security researchers. You can either search for an APK or upload one, and it's going to do a dynamic analysis of it and give you some information on the URLs or the IPs that it's connecting to and the function calls that it's launching when you install the application. So that allowed us to gather information on each of the groups and have an idea of the different IP addresses each group is connecting to. So here we're giving you a summary of what we found. The first 7 groups, here is those, with the grouped APKs. You have the number of APKs for each of them. You see what it's faked as, and you can also see, for example, the different IP addresses or URLs it's trying to connect to. When we looked at these specific servers, what we found is most of them were either flagged by antiviruses as malicious or related to already known malware operations. So we kind of concluded that these APKs were obfuscated because they were malicious. We also had an 8th group that had 60 APKs that we couldn't group together, so they were kind of unique. And we found our 3 APKs we obfuscated and mentioned earlier, as well as a 4th one that we obfuscated too. You're going to see why in a bit. So this concludes our first step on service usage. What it tells us is that the number of customers, based on what we're seeing, is not close, to 1,000 or 100,000, but probably more around, 10 or 20, based on the group APKs. Then we looked at efficiency. The question was, can the service successfully conceal APK's maliciousness? Is it actually working, right? So to do so, what we had to do is to assess if the obfuscated APKs found on VirusTotal were detected by antiviruses. First thing we did is upload the original APKs of the 3 that we obfuscated. And here you have the results on the number of antiviruses detections. Once we uploaded the obfuscated version, we found interesting insights. So what you can see is from the 2 highly malicious applications, so the Android Locker and the SMS Stealer, the number of detections decreased by about 50% for both. However, for the potential adware, that wasn't much, detected by antiviruses, only 2, because maybe it was not necessarily an adware, it was potentially malicious. Well, the number of detection in this case increased to 10, and that's kind of odd, right? You would expect it to decrease. So just, to make sure that this was not, a feature of one APK, we obfuscated another one. It was an application that was simply, printing hello world on the phone. And it had 0 detection at first, and with the obfuscation, it ended up with 8 detections. So what does that tell us? Well, it tells us that potentially the obfuscation service is, efficient at decreasing detection only for highly malicious applications. And maybe it's been so much used by malicious actors that now, machine learning models from antiviruses now detect the obfuscation service already, as malicious, even though they don't necessarily know what exactly the application is doing. We also looked at, the whole sample of the 3,000 applications, and what you see is basically the same kind of results. So in terms of detections, from these 3,000, the minimum was 8, the maximum was 32, but on average, all of these applications were detected by 18 antiviruses. And most of them were tagged as HQR dropper, banker, or Cerberus. So it was detected as malicious. That closes our second, theme, efficiency. And what it tells us is it's not necessarily, it's efficient, but depending on the kind of application that is obfuscated. Then we looked at the potential revenue. The question was, is it profitable? Like, are they making a lot of money with this specific service? So we couldn't, definitely assess how much money they're doing. So what we did is develop basic revenue scenarios that would give us a lower bound. We used the 3,000 APKs that we found on VirusTotal and then the prices that were available on the platform. So remember, we presented it earlier. It's about $20 for one APK, $50 for 3. And then you can, for example, pay $150 for an access for a month for the API. So if we calculate 6 months, so this is the time span that the APKs that we found on VirusTotal were submitted. And we can estimate a lower bound revenue for these APKs based on the price that I just mentioned. So we have two scenarios. The first scenario is conservative. So we're assuming that even though they're different, let's say that if these 3,000 APKs were all obfuscated with one API access of $850 a month, then over 6 months, the operators behind the service would have made about $5,000. If we have a more optimistic scenario, in this case, we go, at the opposite completely. We say that these 3,000 APKs were rather bought at, one single price, the highest one of $20 per APK. And in this case, what we could say is, well, the operators behind the service would have made $61,000 for 6 months. I mean, it's quite impressive, but it's unlikely just because in these APKs, there are some that we sent, and also because some of them are grouped together, so we know that they were mainly probably from the same group. So it's unlikely it's at the higher bound. What we think it's likely to the lower bound. However, we don't know exactly how much. What this tells us is, however, it's far away from the millions of dollars that some reports talk about when they estimate the revenues of such service. This leads us to our the fourth analysis, potential competition. So the question here was, are there competitors? Is it easy to find such a service when you want to obfuscate APKs, and are there lower prices? So this could give us an idea, right, of the obfuscation-as-a-service business context. So what we had to do in this case is find potential competitors. Luckily for us, we had access to Flare Systems and Sixgill. Those are two darknet monitoring platforms that are highly efficient. So what we could do is basically just search for crypt services for APK, Androids, or obfuscation service. And we ended up finding 6 competitors. So 6 individuals or groups, we don't know, that advertise services for obfuscation of Android applications. Here we give you a summary of each of them. What you can see first is they are advertised on various underground forums, just like the FTTKit service that we investigated. And also, maybe it's hard to see it now exactly like this, but what you could notice by looking at the prices and what was advertised on the platform is the prices of the competitors are slightly higher. When we looked at the advertisement as well, we noticed that no competitor advertised a platform with an API access like the one that we investigated. And they all mentioned that for purchases, you had to contact privately the individuals via Jabber or Telegram. So that tells us that the obfuscation service that we investigated may have had a competitive edge by offering a platform where you could log in and obfuscate your application automatically without talking to anyone. This kind of bulk, let's say, process maybe also allow the operators to decrease their prices. However, as we're seeing now, it has its limits because the service efficiency is not that good. And also right now, it's actually not working anymore. The platform is not available online. So that closes our idea of let's say, our section on the business of obfuscation, in which we kind of went over usage, efficiency, potential revenue, and potential competition of the service investigated. Our conclusion from that specific part is that the service we investigated was average. It had a limited clientele and an average revenue. But what's mainly important, or most important, is that it seems to benefit large-scale attackers. So these specific obfuscation-as-a-service, because they only decrease the detection rate of highly malicious applications, it kind of tells us that those who would pay such high prices are those who would want to, target as many people as possible, and just by seeing a slight decrease, they can actually enhance their number of victims and the potential profit in the long run. We conclude from our analysis as well that, well, let's say we want to give group props to the good job done by the security community in the past years, because basically it seems not to be that easy to do an automatic obfuscation as a service. So with more and more models that detect malicious behavior, what we're seeing is it's not an easy endeavor, to provide such a service from our analysis and our perspective, obviously. So if you want more information, or I wasn't clear in this presentation, everything is available in the paper that we published at Virus Bulletin, and it's going to be available on the Virus Bulletin platform. So we highly recommend you download it and read it. And if you have any questions, we will be available on the platform for the next 2 days. So we thank you very much and wish you a great day.